So hello friends, in today's video we will discuss about I2C communication protocol. So basically I2C means inter-integrated circuit, and it is a embedded communication protocol. So basically it is a serial communication protocol used for communication between microcontrollers and peripheral devices. So let's understand. Uh, so this is used for the communication between microcontrollers and peripheral devices such as sensors, double EEPROM, RTC, ADCs, and DSA. Okay, so let's discuss about the key features of I2C communication protocol. So first feature of I2C is it use two wires basically. For one is used for the data transfer, another is used for the clock signal. Okay, so here we are able to see SDA line. So this line stands for serial data line, and it is used for transferring the data between two devices. Okay, another is SCL line. So this line is also called as serial clock line. Okay, so the purpose of SCL line to carry the clock signal. Okay, so without clock data cannot be transferred in I2C communication protocol. Okay, so clock is very important. Okay, so when you are doing implementation of I2C, then you have to take care of the clock signal. Okay, otherwise you will not be able to implement or you cannot transmit any data through SDA line in I2C communication protocol. And let's see other feature of I2C. I2C supports multiple masters and multiple slaves. Okay, so in the coming videos we will understand what are the slaves and what are the masters basically, or we will understand the concepts behind the masters and slave. Okay, how master works, how slave works. Okay, and other feature of I2C is it is a address based communication protocol. So basically each slave has a unique address. Okay, each slave has a unique address. The size of address is 7 to 8 10 bit. Okay, either 7 bit or 10 bit. So because you are implementing because in I2C you can use multiple masters, multiple device, multiple slaves. But how the master will communicate with the slaves? Okay, so there should be some kind of addressing of the slaves. Then only master can talk to slave. And a part of it, the in I2C we requires pull-up registers on both SD and SCL lines. Okay, so don't forget about the pull-up registers in I2C. So let's see the advantage of I2C communication protocol. It requires less number of wires, support multiple devices on the same bus. Okay, so you can use multiple devices on the same bus, and hardware implementation is simple in I2C. It is a address based communication protocol, so there is no conflict between the master and slave communication. Okay, so master will talk to assigned addressed slave. Okay, so this is the advantage of communication protocol, I2C communication protocol. And let's see about the disadvantage of communication I2C communication protocol. So basically, the first disadvantage of I2C, this is slower than SPI communication protocol. Okay, so sometime we discuss about which protocol is fast, like either I2C or SPI. So your answer would be I2C communication protocol is slower than SPI. And other thing, you always require pull-up registers. Okay, so if suppose if you are not using pull-up registers, then again you will not be able to communicate to the, or you will not be able to transfer data on the SDA line in I2C communication protocol. So always remember that pull-up registers are highly used or required in I2C communication protocol. Okay, so other disadvantage is like it's a short distance communication protocol. Okay, so it's a distance and speed is limited just because of bus capacitance is high. Okay, so this is these are some disadvantages of I2C communication protocol. Let's see the standard I2C speeds. Okay, so basically there are modes in I2C communication protocol. So the speed of I2C is between 100 kbps to 3.4 mbps. Let's see this table. So this table is being divided into two sections. Number first is mode, another is speed section. So here are standard mode. In a standard mode, the speed of I2C communication protocol is 100 kbps, and fast mode the speed is 400 kbps, and fast mode plus the speed is 1 mbps, and high speed mode 3.4 mbps. Okay, so in I2C the speed is divided into the modes basically. Okay, and every mode has a different speed rate. Okay, so this table bit will give you the clarity so that you could understand that which mode has what which speed rate. And let's see the comparison between I2C and SPI communication protocol. Okay, so first we see the feature, and then I2C and SPI. Okay, so let's see the number of wires. In I2C there are two wires used, but in SPI there are four wires are used. Addressing. Okay, so addressing is used in I2C, but SPI has no addressing. It is SPI is not address based communication protocol. And speed is lower than in I2C the speed is lower, and SPI is higher speed. And pull-up registers in I2C, pull-up registers are required, but in SPI pull-up registers are not required. Multi-master supports, yes, I2C support the multi-masters communication, multi-master things, but in SPI it is not, it is limited. So basically guys, we discussed about important facts of I2C, and we will see the bus architecture and communication sequence in another classes of I2C. So thank you for today, and if you like the video, and for the more concept and more videos, you can subscribe or like the channel.